Video.
Okay.
Hi, my name is Brianna Bloss,
I'm Stephen Halsey.
And I'm Blake Bryant.
and this is our project for the Miami Housing Mapping Project.
So basically what we did is we took all our data from Realtor.com. We took 50 different homes in Miami and we looked at the latitude and longitude for each, which were used to map all the points. And then we also had 4 quantitative variables and 3 categorical variables. The bed and bath for each house, the square footage, price, and then ocean view, beautiful and renovated or not.
From this graph, we can see that our data was right skewed. You can also see that there are 4 outliers in the histogram plot. But because we had 50 points, we decided to continue with our analysis. Furthermore, the mean is around $750,000 for a house in this area.
So this is just a map using our latitude and longitude to show our quantitative variable of square footage. So the size of the dot correlates with the square footage of the house. So the larger dots, such as this one and this one, mean that it's a larger house, and then obviously the smaller dots represent smaller square footage. Furthermore, we then analyzed a qualitative variable on our map, also using the latitude and longitude, the blue dots representing ocean view homes, and the red dots not being ocean view.
So how did we separate the tests from the training set? Basically, we took the top 80% from the data set, making that the training set, and called the remaining 20% the test set.
So we went through a number of models to see which one was the best model to predict housing prices, and in this model we can see that we did a forward stepwise regression, and from the step history you can see that square feet was added first, which shows that it has the biggest impact on housing price in the area, followed by ocean view, beds, renovated, and beautiful.
The next set we did was a backward stepwise fit, and here we see that the items that were removed were bath, beautiful, and renovated, and it had a resulting R squared adjusted of 0.65.
And then our third model was a forward stepwise. We can see that bath, beautiful, and renovated was also removed. Square footage was the best predictor, and our R squared adjusted was 0.652.
So based on the cross-validation test, we took that 20% of the data points and we then went through the 3 models that we just did previously, and based on these models we can see that the highest adjusted R squared was 0.7359 for the backwards stepwise regression. However, we decided that because this test set only included 10 points, that it wasn't a big enough data set to be an accurate predictor of housing prices.
So with that, we decided to conclude that our best model was a stepwise forward, with the stopping rule being the p-value threshold. This equation up here represents the variables in the best fit model. So it included the bed, square foot, ocean view, beautiful, and renovated. And then we went through and we tested our assumptions. So for linearity, we see a slight S shape here. For equal spread, we unfortunately see a little bit of fanning. We do have independence since all of the data points were randomly pulled from Realtor.com. And then in regards to our nearly normal, we concluded that it is right skewed. However, because we have over 30 points in our sample, we still can conclude that it is nearly normal, and it goes through with that assumption.
So in conclusion, we said that our best fit model is the forward stepwise, and we wanted to say that based on our specific data, we have come to conclude, based on what Bree just said, that the mild S shape in the first graph, the linearity graph, and the fan shape are both they both indicate that this is not strong enough model to be an accurate predictor of housing prices in Miami.
Thank you.
Thank you. Is that kind of what we wanted?
Yeah.